Go, we are live.
Hi everyone, this is John Ogunje of Gigatech International. If you are just tuning in, today we just want to test a system. This setup is called a DC pulse motor. You understand? It's called a DC pulse motor. Although I've explained in the previous videos if you go to my page, you see them there. But this one is just the latest. You understand? The reason I'm doing this is just to, it's kind of inquisitive. I just want to see the facts, the true statement about this system. Some people are saying that it doesn't charge battery because it's a kind of radiant energy and all that. You understand? I just want to prove one or two things. Yeah. Um, so if you are with us, if you have any question to ask, just type it there. I will always answer. So let me just make a simple recap. We'll see they use breaking for people not to understand the grammar not too much. So this thing where you see that is here now a kind of generator. You understand? It's a kind of generator. First of all, make I tell you what are the parts where they here. We have 4 major parts where they here. These are coils. All these ones, if you count them, are 16 numbers. They are called bifilar coils. Why they call them bifilar coils is that we wind down with 2 parallel coils. So now here be the start. We will take start. Then you come put on for hand wound machine. Get hand we will take the one. You don't wind down. Here be the end. So that's what they are called bifilar coils. Now 2 coils, parallel coils. They know they join. So you get. So now so we take the format. And here we call and put. So we have 16 of that there. So you see 16. They are they get position we will take the fix them. Because first of all, you first use ruler to do them so that you get accurate positioning of this bifilar coils. So as this one does so now, we have each coil there now has 2 coils inside. You understand? So with the total of coils with the here, I mean circuits. This one are 2 circuits now. 1, 2. You get? So now 32 now there. So you understand? And the magnets, second component we still there, that be magnets. These are just ferrite magnets. These are ferrite magnets. That be the second thing we did this setup. Then the third thing now battery. Battery must be. So you will get 2 sets of batteries. You understand? We just bought these are new batteries. The ones that I had before, they are more or less dead batteries. This one is already dead. But I just want to manage it to kind of demonstrate what we have to do today. This one are new batteries. You get? So you have the coils, you have the ferrite magnets, you have the batteries. Now 2 batteries there. You have this is the source battery. And this one they cause the mechanical motion where they make this magnet move. The magnetic rotor, if we call it like that, to make them they move. You understand? Then as they move so it they generate what they call back EMF. Back EMF. That back EMF they result when which one I take give example now. Notice as this one dey here. If you go like once you on and on, you go push as it dey enter this angle so. You understand? As this thing dey move so as it cut am, as they enter the comot finish, electromechanical pulse will be generated. That pulse wey this thing go generate is as a result of the collapse of the feed. I don't know how to explain it to you understand. If this thing cut comot, as e dey here so magnet dey cut across this thing, but as e dey comot so, as e dey here so, that interaction, that magnetic don comot, but you don induce feed here. So as this feed dey collapse, now be that back EMF wey go come out from there. You understand? Now we dey call am electrical voltage spike. That spike at times dey reach 200 or 300. So the thing don damage many of my meter. If you say, you know, if you measure am, we have very high voltage at the lowest minimum current. Current is more or less zero, very low current, but the voltage dey high as this thing dey roll. I no be very good teacher, but make I try explain. I'm excited. Wow. So where I stop? So as these two dey interact, you know say na magnet now. All of una don see magnet. If you carry iron here and go hold am. So now so the flux dey cut across this thing. So as the feed here degenerates, as it collapses, high voltage is generated inside the coil. So this, you see circuit wey dey here. See one circuit wey dey where I hide for them. I just keep am there. Now 4 MOSFET dey there. Can I come here and show them? Now I explain wetin dey there. You see, those 4 are MOSFETs. MOSFET dey there. That one wey dey there, now the voltage regulator. That one wey dey the end, so that's the voltage regulator. All this TLP, this and this, now drive. That drive did there so that it will make the switching very efficient. You understand? So this diode, so what you see here, so all these diodes here, now they direct the electrical high voltage. You go come the dump am for this capacitor. You understand? So you go dump am for this capacitor. You can have 10 capacitor, doesn't actually matter, 5 or 6. Just put capacitors there. You get it? So you go see this place now, this flip-flop wey dey here, so they make papa. So as they make papa, so now so they carry the energy wey dey here, they dump am for the battery. You understand? Because the battery get low impedance. So as this thing they do so, I say they dump am. This one a flip-flop, they dump am for this battery. Then the battery will start to grow. You understand? So the process where this thing they roll, that they call radiant energy. But here, what I want to point out be say, although this one are part of radiant, but now pulse charge system, now pulse charge. As that pulse come in, this MOSFET where you see here, so all this battery, now the drain a day. So as the MOSFET on, via that this thing, as it on, it go draw all the charges where they this capacity, go draw them. Now their current they come in. So this kind of configuration is called, it's a forced charge, where you go draw current. You will see when I go show and just on, you will see the current. Originally, if you on them, the system was supposed to take up to 1 amp, but because of this pulse charger, they go up to 5 amps. But as it come the charge, once the battery don't full, this will come down to 1. You understand? So they charge very efficiently, and you know the losses not there, heat not there. Just as you get all this normal charger or solar panel, those are positive charging, and heat they always they follow. So this system is very good for all this type of batteries, as maybe for backup. Now it gets used. So that is for that. I don't know whether okay. See another one where I hide for them. Stand there. That one are the LVD, low voltage disconnect. What did that one mean? Me say, you get where this battery will work, reach. If they work, they drain as small, but it they take time. Now small they take, but maybe you know they have, you're not supposed low pass, say 22.5 or it's okay 23. Depends on where I set and put. Once it reach there, it will cut off the whole system. The machine will stop by itself. Then it will show light. Get one red indicator light we did there. It will sound a very small, but if it work, that blue will show. You understand? I always draw one kind, but the purpose of this is just to test. So all these ones are load. So what we want to do today, I'll use until run and try to drain the battery as power of 50 drainer, maybe like 2 minutes or 3 minutes. I will drain them. Then you will see for here the potential level of these output batteries. For now, the day 25.24. We'll run all these things. We'll drain them. Then we'll on the system. We'll see as they charge. Oh yeah, come on this simulator. On this. Yeah. Stop you. On that one, please. These are inductive loads. What's going on? Alright. Upper. You understand? Definitely the battery will come up again. So Moku on and Moku C. So this battery, they depict the potential level of this output battery. Why this one? I connect charger I put to because the battery don't die. I just want to make this voltage dey constant. 27.9. Then this one are the ammeter where they measure the current when they come up from here, they enter this machine. This rotor. Wetin be ammeter? Now meter where they measure current. Voltmeter they measure volts. So if you want on go on for side there. Bros, go on. You see, go on. Wash your battery. Wash that one. You give one small kick. So. Then see the current. See the current. So now you go to start. As the thing they don't the charge full, it go drop. It will drop down. So it's going up. So more just time for 5 minutes. You get time there. Time it for 5 minutes, honestly. So this machine now, if you want rate time now actually if you want rate something now, what did they produce? Now you tell rate time. So as this one stands now, just as I was saying before, we have 16 magnets here, 9 day here. You understand? And we can't get how many coils? As I said, 32 coils. That also. So if you multiply 32 by that 16, you are going to get 512 pulses per revolution. So that's the capacity of this charger. So if you go around, so maybe start from here, go around, can't stop here again. 500 electrical spark, high voltage spark, don't enter this capacitor and it don't enter here. That is the meaning of it. So this is 500 per revolution DC pulse motor. You can have more than that. Depends on the things we want use and put. You understand? You know they make noise, doesn't make noise. Doesn't make noise. You know will make your battery they heat up. Like the way I want to use this my own now, as my solar they work. This one will just there they run. They all live on there, just they run. So in case we NEPA not just the solar doesn't fuck up, then I will just switch to this. So that is the purpose I just do what this is. It actually charges. You understand? If you charge this battery, for example, you have another 2 sets of this one, new one. Oh, you can't use this charger, and use this pulse motor charger. This one go off. This one go still day. That phenomenon I can't explain it, but you go use them. You go just use them. They go. You know they quick drop. Cannot explain that now, but now be the thing where I notice. Understand? So that is for that. You don't timer. How many minutes now? You know what's your time?
We have 3 minutes. 2 minutes to go.
Time to go. So the actual time where you go, if you drain this battery now, the actual time where I take test am na 2 hours 40 minutes when this source is constant. The size of the battery now be 120 amps hour. Put am for inside me, yeah. It's 120 amps hour. Those na small battery. This side, you don't write am there. You don't write am for this side.
No.
Go see the carton there.
Look at
Bring the carton. I want 20. So, maybe na the side way inside wey we close and there the way you face and there you dey. So na 120. So you want enjoy this type of something, you get bigger bank. You understand? You get big bank. Then your pulse wey dey generate here, you go increase am. You get. So na so e be. So as in the roll now, in the dump energy here, this one dey go up. You understand? So that is that. You no dey make noise, you no dey pollute, and just quiet. So the next one wey I wan do now, I want to increase it, but it will not be as big as this. Na just small something wey I wan generate like I think wetin I calculate na 2,460 pulse per revolution. That one go be 48 volts. This is just 24 volt setup. So when you dey talk of bulk load, you need to increase am, because the higher the voltage, the lesser the current. If possible, na components wey no too dey here, for take am go 96. Now you go enjoy am well. This thing go dey fly, go be like plane. Yeah. So that is that. I no be good teacher, but I just dey talk the way I fit talk. So if anybody get question, just feel free to ask, then I will try to answer. Thank you all. Thank you and out.